way if you miss anything, I'll just upload it onto YouTube. So we left off in this problem. So in case you've forgotten, we were doing expected value. So the formula for the expected value is the summation of x times p of x. So that's how we're going to find the expected value. So let's go ahead and read this problem. So it says the company estimate that 0.7% of their product will fail after the original warranty period, but within 2 years of the purchase, with a replacement cost of $350. If they offer a 2-year extended warranty for $48, what is the company expected value of each warranty cell? So the first thing you want to notice that we want to do this expected value, because they tell us to do the expected value, but we wanted to do it for the company. So we don't want to do it for the person buying the warranty. We want to actually do it for the company. So for the company, for the expected value, you do want to see a positive, because positive means they're gaining money. A negative means they're losing money. So for a company, you never want to be in the negative, because that means they're going to be losing money. Cool. So you have your x, your p of x, that should always be the same. The only thing that should be different is these value over here. All right. Cool. So if you look at it, they want to know what the expected value of this insurance, and for the insurance, they're telling you the product will either fail, they tell us fail, and not fail. So that's what we're gonna put here. We're gonna put, oops. So we're gonna say if fail or not fail. All right. So let's go ahead and do this problem. So for the problem, we want to find the probability that the item or the product will fail. So what percentage of the time does the product fail? And if you want, you can type it into the chat. All right, so it is 0.7, but you have to be careful with the 0.7 because actually 0.7%. So that means it should be 0.007. So probably that will fail will be 0.007. All right. So that's the probability that the item or the product will fail. So if you want to find the probability that it doesn't fail, what you want to do 1 minus 0.007, and you get 0.993. Any questions so far? I got the 0.007 or 0.993. Cool. All right, so up next we're gonna do is find x. So x is pretty much the gain or loss of the company. All right, so if the product doesn't fail, that means the company will get $48. Because if you look right here, here's the $48. So that's the cost of the warranty. So if the product doesn't fail, that means the company gets to keep the $48 and they don't have to replace the actual product. So they get a profit of $48. But the thing is, if the product does fail, they have to pay $350 to replace it. But the thing is, they're not out that entire $350 because they still have the original $48 they collected for the product. So you want to do 48 minus the 350, and you get negative 302. All right. Any questions so far? I got negative 302 and the 48. All right, cool. So up next, what we're going to go ahead and do is multiply. So we're going to go ahead and multiply these two, and you're going to multiply these two. So we're going to say negative 302 times 0.007. We're going to see what did that give us. And then we're going to do 48 times 0.993. So I'm going to switch this over to Classica. Okay, how did I get what, Fidelia? So the 302, we get it over here. So if you do 48 minus the 350, 48 minus the 350 will give me negative 302. So that's how you get the 302. So the reason why you're subtracting, because you first go, the company is losing $350, but the thing is they're not losing the entire $350 because they still have the original $48 that somebody paid for the warranty. So they're not out the entire 350 because if they do have to pay out the 350, they still have the original $48. So that way you do 48 minus the 350. All right. So let me switch it over to class calc, and I'm gonna go ahead and make these multiplication. So let's say class calc. All right. So for class calc, we'll do negative 302, and we're gonna multiply this by 0.007. So if you look, we get negative 2.114. So let's say negative 2.114. Then we're going to say 48. We're going to multiply that by 0.993. And you get 47.664. Then what you're going to go ahead and do, you're going to add those two values. So we're going to get negative 2.114. We're going to add that to 47.664. So we'll say negative 2.114 plus the 47.664. And you get for your final answer 45.55, and that's your expected value. Cool. All right, and that's it for that problem. So that's it for parts, well, for this last problem. Any question in regard to how I did this last problem? Cool. All right then. So let's do part D. So for part D, it's a different problem, but same concept. So for this one says the iPhone 100 has a 15% chance that their screen will break. If the warranty for the screen costs $10, it costs Apple $159.99 to repair the broken screen. What is Apple expected value on the warranty? So same thing, if you look at it, it says expected value, and we're doing this for Apple. So we're gonna go ahead and make a box again. We're gonna say this. So we'll say X, we'll say P of X. All right. So for this one, what can happen to the iPhone? What are the two scenarios that could happen for the iPhone? Okay, if you look at it, they tell us like either the iPhone. Oh yeah. So the two occasion is that they're breaking or not breaking. So we'll put break. Oops. And not break. Cool, good. All right. So let's go ahead and do the percentage. So what's the percentage of the time that the iPhone screen will break?
0.15.
Cool, 0.15, perfect. All right, so if I know the percentage that will break is 0.15, in order to find the percentage that is not gonna break, you take the complement of that. So do 1 minus 0.15, which is 0.85. All right. Everybody get how I got the 0.15 and the 0.85. Cool. All right, so remember, when we're doing the X value, you have to figure out who are we doing this in relationship to. So for this one, we're doing this in relationship to Apple. So we want to see when does Apple is going to make money, when is Apple going to be losing money. So in this case scenario, if the screen doesn't break, Apple is going to be making money because they don't have to pay to get it fixed. So if the screen doesn't break, how much money do Apple gain?
$10.
Cool, $10. All right. So up next we're gonna do for when it breaks. So when it breaks, Apple does have to pay out because they have to fix the broken screen. So for this one, they have to fix the broken screen, which costs $159.99. So you want to represent that as a negative because they're losing that money. But the thing is, you always have to take into account is always the net profit because they're not out the entire negative. Well, they're not out the entire $159.99 because they originally got the original $10 that you pay for the warranty. So what you want to do, you want to say 10 minus minus 159.99, which will give you a negative 149 with 99 cents. All right, so that's our X and that's our, well, that's both of our X's and both of our probability. Any question in regard to how I got any of those X value or the probability?
No.
Cool. All right, up next, we're gonna go ahead and do, I'm gonna switch this over to class calc where I could do the math for this portion. So let's switch it over to class calc. All right, so let me erase. Cool. All right, so the first one we're gonna do negative 149.99, and we're gonna multiply that by the probability of that event occurring, which we said was 0.15. So you got negative 22,4985. Cool. So that's when you multiply the first row together. So now we're going to multiply the second row together, which is 10 times 0.85, and you get 8.5. So far we got negative 22.4985, and when you do 10 times 0.85, you get 8.5. Any question in regard to those two multiplication or operation result?
No.
All right. So the last thing what we're going to do, since we're trying to find the expected value, we're going to just add the two. So we're going to say negative 22.4985, and we're going to add this to 8.5. So we get the expected value to be negative 13.9985. All right, so let me switch it over to the iPad. All right, so if you look right here I got the negative 22.4985, and I got that by multiplying these two values. And then I get the 8.5 by multiplying 10 by 0.85. And then if you add the two, you get negative 13.9985. So what the EX represent expected value. So this is expected value. Cool. So the expected worth of this insurance policy that Apple is giving is negative 13.9985. So the thing is, since it's negative, that means every time they sell this warranty, they're losing money. So do you think that this warranty, the way they have it right now, is a good warranty for Apple?
For Apple, no. But for the customers, yeah.
Yeah. So for Apple, yeah. So for Apple, this is a bad policy because every time they sell one of these policies, they're pretty much losing money. So if Apple wanted to gain money, what can they adjust that will make them well, to make their profit go up?
Make the warranty more.
Yeah. So they could adjust the warranty. So yeah, so they most likely want to adjust the warranty. So instead of charging $10, they might want to increase that amount. Because if they keep on selling the warranty for just $10, they're losing money every time they sell this pretty much warranty. So they do want to consider increasing it. For that way, they're not losing money. For that way, they could be gaining money. All right, but that's it for that last problem. Any question in regard to that last problem?
No.
All right, so let's scroll on down. All right. So up next, we're going to go into how to find standard deviation. So the formula for standard deviation is this one over here. The top formula that I have, this is for variance. We usually don't use variance that much, so we're not going to really focus on this, but this is for variance. This is for standard deviation. But for right now, we're going to focus on this. So let's go ahead and find the standard deviation. So for this one, we want to find the standard deviation of this data set. So for this data set is how many DVD a person rent from Redbox during a single visit. So right here, oops. So right here where it says x is equal to 0, 1, 2, 3, 4, 5, it is saying that they rented out 0 movie, 1 movie, 2 movie, 3 movie, 4 movie, 5 movie, and so on and so forth. So in order to find standard deviation, we're going to try to get all of this. So you do standard deviation of x is equal to square root of summation of x squared times p of x. And then we subtract that by mu squared. So that's what we're going to try to do right now. So right now we're going to focus on this part right here where it says x squared. So where it says x squared, that means we're going to get the x value and we're going to just square it. So right here where it says 0, we're going to do 0 squared, you get 0. Right here you're going to get 1 squared, so you get 1. Right here you get 2, so you do 2 squared, you get 4. You get 3 square, you get 9. You get 4, so you get 4 square, 16. You get 5 square, you get 25. All right. Any questions so far? I got any of the red numbers? All right, sweet. So up next, we're going to go ahead. And now if you look at the formula, we're actually going to now go ahead and do this portion right here. So if you look at that portion, so you get x squared and you multiply it by p of x. So we're going to go ahead and do this portion right here. So I'm going to get this and multiply it by that. So you get 0. Oh, sorry. I picked the wrong one. We're going to get these two and just multiply them times each other. So first one we're going to do 0.06 times 0. You get 0. Now we're going to multiply these two together and you get 0.58. Now we're going to multiply these two numbers together and you get 0.88. All right, so far, any question on how I got any of those three values? All right. So up next, we're going to go ahead and do 0.10 multiplied by 9. That could give us 0.90. We're going to do 0.03 times 0.6, well, 0.03 times 16. That gives us 32, 48, 0.48. And you go 0.01 times 25, and you get 0.25. All right, so that's how we get this portion over here. All right. Any question how I got the portion in blue?
No.
Wait. So if you look at that portion in blue, right next to it, it had this symbol, which that symbol just means sum. So that's telling us to add them up. So what we have to do, we have to get all of these numbers and just add them all up. So we're going to say 0 plus 0.58 plus 0.88 plus 90 plus 0.48 plus 0.25. And we just want to see what do they add up to.
3.09.
109.
What was that again?
3.09.
Cool. All right. Everybody good when added those value, when you add all of those values, give you 3.09?
Yep.
All right, perfect. So instead of having this, you put 3.09. All right, so now let's look at this portion over here. So for this one, they want the mean. So if you look at that portion, we actually already found this one. We actually found this one last time we met up, last Wednesday. So if you actually go back to your notes, and if you go to, let me see, I think page 4. Oh, but page 3. If you look at page 3, we already found this mean.
1.5.
We found it to be 1.49. So that's what I'm gonna put for that mean. So 1.49. So ratio 1.49. All right. Any question where the 1.49 come from? All right, so up next I'm gonna switch over to class calc and I'm gonna calculate this in class calc. So in class calc, we'll say square root 3.09, and we're gonna subtract this by 1.49, and don't forget to square this portion. And you get standard deviation of x is equal to 0.932. All right, and that's our final answer. So that's how you find standard deviation. So for this one, it's easier to kind of go with the table. So just remember, yeah, you first have to find the mean. But in our case, if we had already found this mean on the left lecture, we already had that, so we didn't have to worry about that. So we just had to find x squared and then find what x squared times p of x is. And then you just add all of those value up. But that's it for that last problem. Any question for that last problem?
No.
Right. So up next, we're going to go ahead and start doing something called a binomial probability experiment. So for a binomial, you're going to have a certain amount of criteria they have to check for to make sure it is a binomial distribution or a binomial experiment. So the first thing that you kind of want to have for a binomial, because if you look at the word binomial, bi means essentially two. So there should only be two categorical options. So you could easily place it as a success and a failure. So you should be able to label them as a success and failure. So the second one is experiments must have a fixed number of trials. So that means they have to tell you how many times they're gonna have an experiment. So they have to tell you we're gonna have like 5 experiments or 20 experiments or 7 experiments. But they should tell you at the problem, it should tell you that they did the experiment so many times. The third one is each trial must be independent of the other. So one trial or one experiment shouldn't affect the second experiment or the third experiment from occurring. And lastly, the probability of success will be notated as P. Q will be the probability of failure. And both of these, when added together, they should always add up to 1. And that's what the last thing is saying. They say if you get P plus Q, it should equal to 1. So far, any question in regard to that?
Somebody's mic is on and it's really loud.
All right, hold on, let me check the mic. All right, so I think that should fix it. All right, so we're gonna go over the formula for binomial. So this portion over here it's going to give us how many combination we have. So the combination is going to tell us how many total way we could get the certain amount of success. Because whenever we're doing binomial, we don't care about the order of the success as long as we have X many successes. So in this case, we're going to say N is how many trial, X is how many success we're going to have. And if you look over here, this is how we're going to find that combination. So we're going to use this formula, but if you remember for that formula, this formula is just the NCR that we use in class calc. Right. So then up next, this is success, and this is for failure. Oops. So whenever we're doing p to the x power, the p represents the probability of success. X is going to represent how many success do I want. So if I want there to be 3 success, x will equal to 3. So Q represents the probability of failure. So Q will represent the probability of failure. N minus X will represent how many total failure do I want. So one thing you have to know, if I do X plus N minus X, that should always add up to how many trials we have. Because if you do X minus N minus X, that will always leave N by itself. All right. So let's go ahead and let's actually do a problem. So for this problem, pretty much I already gave you everything. So if you look right here, it says probability x is equal to 2. So that means I know x is equal to 2. And I already tell you n is equal to 6, p is equal to 0.3. So everything is given to us. For that way we could calculate it. So let's go ahead and calculate it. So first thing we're going to go ahead and calculate is this portion over here. But we're going to use NCR to calculate this. So that means we're going to do 6C2. Any question, where does the 6 or where does the 2 come from? All right, so I'm going to go over to class calc. Cool. All right, so what we want to do, we're going to go to stats. You're going to go right here. I think it should be, well, it's in basic. So if you see in basic, you see where it says NCR, then you choose NCR. So first thing we're going to do, choose 6. Next one, we're going to choose this 2. And you're done. So you get 15. Right. Was everybody able to get 15 for that one? All right, so let me switch it over to my screen. All right, so right now we just found that this 15 corresponds to this portion right here. So we're gonna say 15 multiplied by p to the x power multiplied by q to the n minus x. All right, so right now we're gonna go ahead and do, you substitute all of the n, all of the x's, and all of the p's and q. So for p, we already know p is equal to 0.30. So they tell us p is equal to 0.30. And if you look at the already told us x is equal to 2. So wherever I see an x, just put a 2. If you look at q, q is always the complement of p. So whatever p is, if I do p plus q, it should always add up to 1. So if I want to find Q, all I have to do is do 1 minus P, which is 1 minus 0.3, which is 0.7. So instead of putting Q, we're just going to put 0.7. And the last thing we're going to do, instead of putting N, we're going to replace what N is equal to. N is equal to 6. All right, so that's how you substitute it into the formula. Any questions so far for the substitution? All right, so no question. All right, so first thing you want to kind of go ahead and do, you want to clean this up a little bit. So you could do 6 minus 2. 6 minus 2, if you do 6 minus 2, that give me 4. So let me erase this. Cool. All right, so if you look at these two, if you look at the 2, if you look at the 4, if you do 2 plus 4, you get 6. So that's how you know you're doing it right. Because those two numbers that I just highlighted, if you add them, they should always add up to whatever N is equal to. So in this case, N is equal to 6. If you do 2 plus 4, it should add up to 6. All right, so if there's no question about that, I'm going to transition over to Class Calc. For that way, you can see how I enter it into Class Calc. All right, so we put 15 multiply by 0.3, and we'll do that to the second power. So the second power in Class Calc will be this one. And then what you want to do, multiply this by 0.7. And you want to do this to the fourth power. So you want to use this button where it says A to the N. And you put 4. And you get 0.324135. But you could put 32.4%. All right, but that's it for that first problem for binomial. Any question for that first problem for binomial?
No.
Cool. All right. So ClassCalc actually have an option for binomial. So in the test or in the quiz, if I don't ask you to do it by hand, you can always use that option. So if you go to stats, if you go to advanced, I think, oh, wait, distribution. Yeah, go to distribution and click on binomial distribution. So you have to put the N. Oops. You have to put the N, which is 6. And then what you want to do is put the probability of P, which is 0.3. And for this one, what you want to do is say PDF. And then you say X is equal to 2. And if you look at it, it'll give us this value, which is the exact same value that we got by when we did it by hand. All right. Any question in regard to how to use it? We'll use ClassCalc for that portion. All right. So let me switch over back. Well, if you're using ClassCalc, you hit the stats button right here where it says distribution/plot. And then right here where it says binomial distribution, you click on it. Oh, not very good like that. But yeah, that's how you get to binomial. All right, so let me switch back to yeah, no problem. So let me switch back to my iPad. so let's do this next one. So for this one, it says a husband and wife want to have 3 kids. What are the probability of having 2 girls? Okay, so we're gonna find what N is, what P is, and what is X. So for this one, how many experiments are they having?
3.
Oh, 3. So each kid is considered an experiment. Oops, sorry about that. Got away from me. So N is equal to 3. Good. All right. What's the probability of success? Or sorry, let's go to X. So what are they trying to look for? Are they trying to look for that they have a male or that they have a female?
A female.
A female. So in this case, our success is that they have a female. If they have a male, it's a complete failure. All right. So what's the probability that they have a female?
50% or 0.5.
Yeah, good. Cool. Thanks, Samantha. Cool. All right. How many success do they want?
2.
2. All right. Everybody go with N is equal to 3, P is equal to 0.50, and X is equal to 2. Sweet. All right, so let's go ahead and calculate this. So I'm going to go back to class calc. All right, so once again, we're going to go to binomial distribution. So we're going to go to stats. You're going to go to distribution / plots. And you're going to go right here where it says binomial - distribution. All right, so in this case, what's my N? Well, my N is 3. P is 0.50. And let me actually just take this one out and this one out, for I don't have any overlapping. All right, and for right now, what I want to do, I want to click PDF. So PDF, you want to tell it what exactly is my X. So in this case, what did we say X was equal to?
2.
2. So you put 2, and you get 0.375. So we get probability that X is equal to 2 is 0.375. All right. Any question in regard to this last problem or part, the first part? Sweet. All right, so let me go over, switch over to my notes. So X represents how many success do you want? So in this case, since I want 3 success, X is equal to 3. All right, so in this one, our N is still the same. It's still going to be 3. Our P is still the same. It's going to equal to 0.5. But what's going to change is our X value. So our X value is going to be a little bit different. Can this one? No, N represent how many trials you have. X represent how many of those trials do you want to have a success. So like, and say, like for the problem that we did, we said we're having 3 kids, but we only want 2 successes, so 2 girls. So N represent how many experiments you're gonna have. X represent how many successes you're gonna have. All right, so let's do this next problem. So we want to find the probability of a couple having less than 2 girls. So if we want them to have less than 2 girls, what does X has to be?
1.
Cool. But we're missing 1.
0.
Yeah, perfect, 0. So you pretty much want anything less than 2 girls. So it could be that they only have 1 girl, but it could also be that they have 0 girl. So we want to find the probability when x is equal to 0, but also when x is equal to 1. All right then. Any questions so far for x is equal to 0, x is equal to 1? Okay, so I'm going to transition over to class calc. So the way that you get, so the way that we got PP is equal to the probability of success. So it's the probability of having a girl, so just 1 divided by 2, so 50%. So I'm gonna transition over to class calc. So I'm gonna show you 2 ways how to do this problem using class calc. And it totally depends on you on how or which approach you want to take. Everybody see class calc so far? Right.
Yes.
Cool. Thank you, Samantha. All right. So there's one way that you could do it. So if you look at this right now, you should be looking at a histogram. The histogram, if you look at it, it's for each outcome possible. So right here, if you look right here, if you look at say 0, comma 0.125, so the first number that they give you is the x is equal to 0, and the second number they give you is the probability. So if I go up here, you notice how it says 1 comma 0.37. So that represents that you have x is equal to 1. The probability of x is equal to 1 at 0.375. If you go on to the next one, it says x is equal to 2 and then 0.375. So that's telling you the probability they have 2 girls is 0.375. And then lastly, the probability of 3 girls, because x is equal to 3, p is equal to 0.125. All right. So by looking at this chart, you should be able to get all of the probabilities. So if you remember, we said x is equal to 0 and 1. So if x is equal to 0, I'm going to use this one. So you see how it says 0 comma 0.125. So I'm going to just use the 0.125. And then all you have to do is add it to the probability when x is equal to 1, which is 0.375. And then you get your answer to be probability that x is less than or equal to 2. Oops. Well, less than 2 is equal to 0.50. So that's one way you could do it, by just using the chart on class calc. Right. Any question in regard to how to use the chart on class calc? All right. So the second way that you could do it, so if you kind of been noticing, whenever we've been doing, oh here, let me take this. Whenever we've been doing binomial distribution, I have been using the PDF value. So we say n is equal to 3, we say 0.50. So if you kind of know it, I've been using PDF. In this case, we're going to use CDF. So C stands for cumulative. So if you kind of think about it, like whenever a teacher tells you you have a cumulative test just mean, or cumulative just mean whatever you have learned so far, all the way to the beginning of the semester, that's where you're going to get tested on. So cumulative for this thing, or for binomial, represent that it's going to get the probability for everything for that x value all the way down to 0. So we're going to use CDF. So if you look at it, it gives you the option where it lets you put what the lowest and what the highest could be. So for this one, what the lowest x value that we wanted?
0.
0. So it put 0. What was the highest value that we wanted?
1.
So if you look at it, it'll say, hey, you only want these two bars right here, and that's equal to 0.50 or 50%. So that's the other way you could do it. And both way will give you the same answer. All right, but that's it in regard to that second binomial distribution. Any question for that binomial distribution? Sweet. All right, so let me switch it over. For that, we can see the next problem on my iPad. All right, so let's go ahead and do this one. So for this one, it says a quiz for a psychology class consists of 10 questions. The questions are multiple choice with 5 possible answers with only 1 correct answer. If the student did not study and is guessing for all 10 questions. Okay, so let's look at this and let's look at why is this a binomial distribution. So for this one, do they tell you how many? So right now the experiment is how many questions can this student get correct? So that's the experiment. So how many time are they doing this experiment? So are they doing this experiment 1 time? Are they doing it 2 times? How many times are they doing it? Cool. So yeah, so for this one, since it does have 10 questions, n is equal to 10. So that's how many questions I have. So for this one, what would be considered a success? So would it be considered a success that they get the problem correct or they get the problem incorrect?
Correct.
Yeah, cool. So X will be correct. So X will represent how many correct answers do they get? So let's try finding the probability of them getting a correct answer. So we'll put P. Cool. So for this multiple choice quiz, how many options does each question have?
5.
Yeah, so it has 5 possible answers. So that means it's divided by 5. How many of those 5 possible answers are the actual correct answer?
1.
Yeah, so you go 1 out of 5. So there's 1 out of 5 are correct. Cool. So if you look at it, for this one, we have n many. We have a probability that's consistent because it's 1 out of 5 for all 10 questions. And X will represent how many correct answers are they gonna get. All right. Everybody good so far on the N, the P, and what X represent?
Yes.
All right, so let's go ahead and find what is the probability of the student getting 1 correct answer. So if we want them to get 1 correct answer, that means X is equal to what?
Point 2.
Well, what is, because you're giving me a probability, but X should always be a whole number. So how many correct answers do we want them to get? Yeah, so we just want them to get 1 correct answer. Cool. So X is equal to 1. So what we're gonna do, we're gonna say N is equal to 10. We're gonna say P is equal to 1 out of 5, which if you want, you could say 0.20, and X is equal to 1. All right. Everybody good so far? We got X is equal to 1, N is equal to 10, P is equal to 0.20.
Yeah.
All right, so let's go ahead and let's switch over to class calc and let's go ahead and do that problem. So we'll say class calc. We'll do share. All right, so have to change this. So we have to change this to 10. We have to change this to 0.20. And for this one, if you look at it, since we only want to find the probability of them getting exactly one question correct, you want to do PDF. Because you don't want a range, you actually just want one value. So for the PDF, what should I say x is equal to? So what should I say my x is equal to? Cool. All right. So you say 1. So let's put 1. So you put 1 right here. And we're all done. So we'll say the probability that x is equal to 1 is equal to 0.2684. And that's our answer for part A. Any question in regard to part A? All right, so what I want you to do, I want you to try doing part B. So part B, you already know n is equal to, well, n is equal to 10. You know p is equal to 0.20. The only thing you have to do is figure out what does x has to be. So try doing that one right now. If you have any questions, you let me know. So you want to use PDF if you're only finding the probability for one x value. So if you know x is equal to like 5, you use the PDF. Or if you know x is equal to like to 20, you use PDF. Or if x is equal to 1, you use the PDF. You use CDF if you want a range. So if I know you want to find the probability, say like from 1 to 5, you want to use CDF because the CDF will give you the range. But if you want to find the probability, yes, a singular event occurring, so singular x, then you want to use PDF. Right. So for this one, what would be my x value if I want a passing grade on this quiz? Cool. All right. So you gave me one of the answer. What are my other answers?
100.
So how would I get 100?
10.
Cool. What other?
80, 90. Oh, 8 and 9.
And cool. Yeah. Thank you. Cool. So what we want to do, we want to find the probability of this person passing. So in order to find the probability of them passing, we have to find the probability of them getting 7 question correct, 8 question correct, 9 question correct, and 10 question correct. So since we want to find the probability of a range, for this one, would you want to find the CDF or the PDF?
The CDF?
Yeah, cool. So you want to do the CDF. Okay, for the CDF, what you want to say that my X start off at 7, but goes all the way up to 10. So let me switch it over to Classical, so that way I can show you that. All right, so in ClassCalc, I'm going to select CDF. I'm gonna clear this. Get this one out. So if you look at it, it says x. So I'm gonna say x, the lowest x is 7. I'm gonna say the highest x is 10. And let me actually zoom in on this. So if you actually look at this bar graph, or not bar graph, of my histogram that I have right here, you can kind of see here are 7, 8, 9, and 10. So if you look at the probability it gave me, it told me the probability that x is greater than or equal to 7. Oops. That's equal to 0.00086,436. So it is very likely that if I'm just guessing on this quiz, I'll get a passing grade.
No.
No, because if you look at the probability, not even close to 1%. So it's kind of telling you, like, if you haven't studied at all for the quiz and you're just absolutely guessing, the chances that you get a passing grade on this quiz is very unlikely. All right, but that's it for that last question. Any question in regard to the last problem?